Hello, I'm Jarso Dida. This is to present multimedia data processing, task 2, which is video processing. From video processing, I implemented real-time violence detection in videos using YouTube-derived action datasets, which is the dataset, one of the datasets from Kaggle dataset. The purpose is to detect either the videos is classified as categories of violent or non-violent. Let me start by presenting about the problems. What problems will be fixed by implementing this project? Actually, this real-time violence detection project is designed to automatically classify videos into violent or non-violent. Now, in today's world, where surveillance systems are increasingly common, manually monitoring for violent behavior is time-consuming and prone to human error. So, this project aims to enhance public safety by providing an intelligent system capable of flagging potentially violent incidents in real time, supporting application in law enforcement, in public transport, in schools, in smart city infrastructure, and manywhere can be applied manywhere. So it is timely topic. So the problem is now manually monitoring for violent behavior is one, time consuming and prone to human error. Then let me say something about dataset 2. As I have already said, I used real life violence situation dataset, which is from Kaggle dataset. My dataset contains 2,000 videos, 1,000 is classified as violent, and 1,000 is as non-violent. Violence videos in our dataset or in this dataset I'm using contain many real street fight situations in several environments and the conditions. And the non-violence one is collected from many different human actions like sport, like while the people are doing sport, eating, and walking. So it is pre-processed. This is now implementation steps. Let me explain detailing in the implementation steps. Different implementation steps are there. The first implementation steps is just I started by downloading the dataset from the Kaggle dataset and upload it into the my Google Drive, my drive. Why uploading it to the drive is important? Because it easily manage and access large dataset, especially during training. And after uploading to the drive, I mounted the drive. By this now, this program is for mounting the drive. Look, as you can see here, this is the program to mount the drive. Why mounting the drive is important is that to connect the collab to Google Drive, so file can be read directly from the mounted bus. Then after mounting the drive, the next step is loading and pre-processing the data. A custom function was created to extract frame from each video and label them appropriately. Videos were organized into violence and non-violence folders to simplify labeling. Each video was converted to 10 frames of size 64 by 64 pixels using OpenCV. Now, just is explaining implementation steps. This is now this program is for importing required library, and this is the program for Loading and the pre-processing data, extracting frames, load the data, just classifying the labeling. Okay, then splitting training and the test data. Look, as you can see here, test size is 0.2 mean 20%, and the 80% is for training. So why loading and the pre-processing is important is that these frames were normalized and shaped into a sequence suitable for training of the models. Then the next step is training and building the model. I used hybrid models, which includes CNN and the LSTM model. The CNN layers extracted special features from each frame, and the LSTM layers processed frame sequence to learn temporal patterns. And then the model was trained. It was trained for 10 epochs. Let's see here. This is the program for building the model. This is the output. Then after building the model, it is trained for 10 epochs. Look, training for 10 epochs or for 10 rounds. For 10 rounds. So I built hybrid models, as I've already said, hybrid models to just on the dataset on 80% of the dataset. Then at the end, I try to evaluate them by using confusion matrix on the test dataset. On the test dataset. Then the model built, let's see the architectures of the models. Now, as I've said, the model is hybrid models, two models. The first part is CNN or convolutional neural network, which includes many layers. For example, inputs of CNN, then after input, convolutional layer 1 to extract features, then pooling, maximum pooling layer 1 for downsampling or for compressing without just removing the important features. Then again, maximum pooling, then fully connected layers, then output from CNN. This output from convolutional neural network is used as input to LSTM model. And this is the explanations. Output from CNN is used as input to the LSTM. So this is what architecture looks like. The output from says, yeah, this, as I've said, the output from convolutional neural network is used as input for LSTM. The LSTM process this sequence to capture motion and the behavioral pattern over the time to give the final output. This video is categories of violent video or categories of non-violent videos. This combined approach enables the model to classify video as violent or non-violent. Then, as I have said, the model trained for 10 epochs or 10 rounds with good accuracy, like 94, something like that. And then I try to see the training accuracy and the training loss curve, which means I try to plot the curves of training accuracy and the training loss as visible here. This is the curve which I plotted to check the progress of training accuracy and the training loss. So as you can see, this is training accuracy. Training accuracy is increasing, and the training loss is decreasing, almost coming to zero. This is also validation accuracy. It is increasing also, but it is not as good as training accuracy. This is the curve plotted. And then the last step is evaluating them by confusion matrix. This is the confusion matrix. Look here. Okay, let me see. Look, this is the confusion matrix. The confusion matrix. As you can see, this is actual data and this is predicted data. Non-violent, the row represents actual class and the while columns represent the predicted classes. Out of all non-violent videos, 132 were correctly predicted as non-violent, whereas 67 were misclassified as violent. For violent video, the model showed high accuracy with 188 correctly classified and only 5 misclassified. This thing, just I tried to train this model many times, but the first time it gives good accuracy, good performance. Then I tried to increase it, but it gives this one. So this is the confusion matrix to classify, to check the test data as it is correctly classified or not. This is all. My time is limiting me. So generally, the purpose of this project is to classify the video from the dataset as violent or non-violent. My time is limiting me. Thank you for watching. Thank you. Bye. Bye. Bye.